Hey everyone, welcome to the next episode of Planet Vulcan. So when I left off in the last video, everything was set up to run, but we never actually tested any of it. So in this episode, we're going to set up the code to create a window and to initialize Vulcan, and by the end of it, we should be able to tell if all the linking was actually done properly. If not, we'll encounter errors and then we can fix it as we go. There's going to be a lot to cover in this video, and it may end up being a little bit long. I'll try not to let it run too long, but it's going to be worth it. Everything we're doing here is going to be crucial to things later on. So first off, let's get the window actually working so we have something running in our code. So we built this window class in the last video. There's window.h and window.cpp. There's nothing in it right now. So first off, since this class is going to handle everything involving the window, we need something to actually create the window. So I'm going to make a function called create. And it's an int because it's actually going to return a value to let you know whether or not the window is created successfully. And then we also need a container for the window. So we're going to use glfw window, and it's a pointer, and we'll call it window. Now this is immediately going to give us an error. That's because we haven't actually included glfw yet. We linked it. So the system does know that it's there. It doesn't know to use it in this particular class though, so we're going to need an include. So we type in include, and for glfw, this is the format. It's glfw/glfw3.h. And you see it's even giving me a little bit of a suggestion there. So now that should come in just fine. And let's also make some private variables here. We're going to go ahead and have the dimensions for the window. Right now we're not going to worry about actually having a resizable window. We'll get into that later. For now, it's easier to just lock it at a particular size. So we're going to do int window width, and we'll just set that at 800. And int window, can't spell at all. It's a little bit tricky to type when I have a mic here. That's okay though. Window height is going to be 600, so just standard 800 by 600, make it nice and simple. Alright, now let's go ahead and fill out that create function over in the window.cpp. So let's drop down here, and we're going to go ahead and define that function. So first off, since we're using glfw, you need to call init. Okay, this is just required. It's the way that glfw works. So glfw init, glwf, there we go. And you see it suggested right here. And you don't need to do anything special with that. You just call that, and that allows you to start up glfw in a sense. Now we need to give it some information about the window that it's going to be creating. Here we go. Now first off, we're actually going to do this twice. The first one that we're doing here, glfw is designed to work in an OpenGL context, and we are not working in OpenGL. So this is telling it not to do that. There we go. There you go. glfw no API. That's what we want. So that's telling it just don't worry about OpenGL. We're doing our own thing here. And we're going to disable resizing windows because, like I said, right now we're just going to lock it to a particular size, and we'll fix that later on. Right now it doesn't really matter. There it is. All right. And now we need to actually create that window itself. So we already have the window pointer. There we go. And we're going to assign it the created window. So to create a window in glfw, the function for it is glfw create window. They made it nice and simple for everyone. And then you need to pass it all of the parameters that it expects. So if you just mouse over it here, you'll see what it's expecting. Not being cooperative. And there's a lot of stuff you got to pass there. You have a width and a height. You have a title for the window. And then you have a monitor and share, which we're just going to set to null pointers for the moment. So all we do, since we already have a width and a height defined, there's window width, window height. Oh, I spelled that wrong, didn't I? Here, let's fix that right now, just because I care. Spelling matters, especially when programming. Alright, let's go ahead and name the window. For now, I'm just going to name it the project title. And then, like I said, just a couple of null pointers. There we go. So that should create our window. And because we did ask it to do a return, we're just going to return 0. That would be successful. We can add in something later on to return a different value if it was an unsuccessful run. So, now that we've got that, since we're going to be using the Vulkan engine that we've created kind of constantly within whatever game we're making, like our tester game, for instance, I want something to kind of identify what is from the engine and what's from the test game, just so we don't get confused. So a good, easy way to do that is to wrap everything in a namespace. So what I'm going to do here, we're just going to go ahead and do namespace, and let's call it, we'll call it Planet Vulkan Engine. It's kind of a lengthy name, but it won't hurt anything. And we're just going to wrap everything in that, the entire thing. Oh, missed a parenthesis. There we go. Let's do that one more time, actually. There we go. Now we have the nice formatting. So what that's going to do is now everything is contained in this namespace, and it's not happy because I haven't done that to the header file yet. We're going to do that as well. There we go. That should fix all our problems. So the reason that's important is that means that now everything that we write within the Vulkan engine is going to be part of this Planet Vulkan engine namespace. So whenever we call something from the engine in tester game, we're going to have to include that with a scope operator. And that'll make it very clear what's being grabbed from the engine and what's from the game itself. It also means that any variables or class names that we're using that are from the engine, we could reuse in tester game and not have to worry about any conflicts, because you always have to include that namespace so it knows that it's coming from the engine. Alright, so let's start actually adding some code to the tester game so we can test things and not just keep writing code about it. So we need a main function, or main class rather. We haven't actually created any sort of entry point for the program yet. So we're going to add a new item in tester game. It's going to be a CPP file, and we're going to name it main. Okay, just standard main class. There we go. And here we go, just int main. Having some trouble typing today. That's okay though. And we're going to use just the standard arguments for main. So int argc char ** argv. Alright, so now we have a main. There's not a lot going on. And we want to link this up to the file that's going to be holding everything for the test game. So let's go ahead, before we get any further in main, and we're going to add a new class. Here we go. And the class is going to be called test game. Or let's call it tester game so it just matches everything else. There we go. Perfect. So we have this now. And let's see what we need here. We need something to actually run the game, okay? So we're going to create a void run, right there. That'll be the function that gets called to start everything up. And then that will call a number of private functions that we're going to create, which handle everything for the game itself. So first off, we're going to have void init systems. That one is going to start up Vulkan, start up the window, everything that we want to happen later on. We're also going to have a game loop. Anytime you're making a game, you need something to run constantly and just keep updating everything within the system. It will usually handle drawing things to the screen because you have to update it multiple times a second. It'll handle input, things like that. Okay? And then we're also going to create a variable for that window that we created a second, or the window script anyway. So, remember how we wrapped everything in a namespace? We're going to call Planet Vulkan Engine, scope operator, window. And that allows us to access that window class. And then we're going to store that in a member variable that we're calling mwindow. That's just so we know that it's a member variable, but you can really name it anything you want. And right now it's still not recognizing it. That's because we haven't included Planet Vulkan, because it's a library now, so you need to include it. And we're going to go ahead and do that. We're going to do Planet Vulkan / window, window.h. And let's see if that does the trick. It's not Planet Vulkan. My mistake. It's PV engine. There we go. That did the trick. So now we have everything there. You know what? Just to make things a little bit easier on us, this namespace is going to get confusing later on. Let's go ahead and call it PV engine as well. That way, there's no issues later on. So I'm going to go ahead and modify the namespaces in window.cpp and window.h. We're going to change those to PV engine. There you go. All right. And so back in tester game, yeah, perfect. Everything works now. So we have that. And let's go to our CPP file. We want to start setting up some of these scripts here. All right, so let's get that run function built. So once again, void tester game run. So once again, like I said, this is going to call all of those private functions that we've created. So it needs to make a call to init systems, and it needs to make a call to game loop. So this would initialize the systems first and then begin the loop. And let's go ahead and get those set up as well. So void, and we have init systems. And so this is where we're going to start using those functions from the window class that we created earlier. So I'm going to go ahead and access that mWindow that we define and call create on it. So this is going to take that window object, sizing, that we had over here in the testergame.h, this PV engine window. It's empty right now. It's a window class, but there's nothing in it. And that's going to cause it to be created using this nice little function that we made here. And then we're going to go ahead and... Actually, you know what? Let's remove the game loop from here. Let's go ahead and put that at the end of init systems. That way, once things have been initialized, we know that the game loop runs. That way it won't start it before we've got everything ready for it. And then I'm going to go ahead and define the game loop down here. We're not doing anything with it quite yet, but it's good to have, just so we don't forget that we made it. If we've defined it in the header file, we should define it in the CPP. So that should do the trick. Now, the game still won't run if we go ahead and hit start, because right now the main function still has nothing in it. So let's get back over there. And since we now have that test game that we've created, let's actually define a test game object. Okay, and once again, it's not going to recognize it unless we include it. There we are. And then perfect. And hopefully that'll catch up soon. Oh, my mistake. It's tester game. There we go. Perfect. So now that we've defined that, that object is going to contain our game itself. And we're going to go ahead and tell it to run. So I'm going to go ahead and put this into a try-catch statement just in case something goes wrong. So try tester game. Test game, because we need a test game there. All right, and run. My spelling is really off. There we are. So that will start up the run function for the game, and then we need a response if it doesn't work. And we're going to go ahead and use some of the helpful error checking. I'm going to include up here std except that handles exceptions, and include iostream. That'll be for an output, so we know that something took place. And inside the catch here, we're just going to do std runtime error, and let's make that constant so nothing gets modified. And we're going to output exactly what happens. So here we go. That returns what the error is. And I'm sorry, that's a function. There we go. And that should give us a nice little output. And then we need to notify whether or not something was successful or not. Since you have this int main, we're going to go ahead and return. And we can actually do, where is it? Exit failure. And right down here, actually I don't really need to copy that, do I? Return exit success. There we go. So that will let us know exactly what happens if it does not run properly. And at this point, in theory, I believe we can actually just run the program. Let's see if this actually gets us anywhere. Rebuild everything. Actually, this may not work because we didn't rebuild PV Engine. Let's see first. Yeah, there we go. So here, let's go to PV Engine. Rebuild. There we go. And let's try this again. Nope. Not a valid Win32 application. That's bad. Let's find out what's wrong. Alright, so I took a quick look and I just made kind of a stupid mistake here. Really should have caught this. You can set the startup project on what you're doing here. PV Engine was default because that's where we started. It was set as startup project. That's where it's going to try and run from. It's going to look for a function, its main function to enter at, and it's going to try and run, and there isn't one. PV Engine is a library, so that doesn't make any sense to start in PV Engine. I completely forgot to do that, so we go ahead to test your game right here, right-click, and hit Set as Startup Project, and that should fix the problem. So, if we run it now, everything boots up nicely. The window goes away almost immediately, because you need something to keep it running, but at least we get one. That's what we want to see. So let's see if we can actually keep it on the screen for a little bit longer. The game loop is what's actually going to keep it running. So, what we want to do is we want to put in a while loop, and that's what's going to keep it updating constantly. And we're going to go ahead and use, if not, glfw window should close. There we go. And we're going to reference the window that we've declared. And glfw poll events. And that's going to check what the user is doing with that window, like whether or not they've hit the X button and it's been closed. So let's see if that gives us something a little bit nicer now. And we have a nice little permanent window there. There's nothing in it. We haven't actually rendered anything. It's going to be a little bit longer until we do, because we haven't gotten Vulkan up and running yet either. But having something on the screen is kind of satisfying, isn't it? So, let's go ahead and close that and move on to some Vulkan. Alright, so before we get too far into the Vulkan section of this, let me go over a little bit of how Vulkan works. So, to set up Vulkan to actually use it, you need to initialize it, then you need to find all of the physical devices on the system, and then you need to create logical devices to correspond with the physical devices. It's kind of a tricky setup, but it'll all make sense when we're done. The important thing, though, is that the Vulkan objects need to be destroyed when they're no longer used. It's kind of like when you allocate memory, you need to return that memory to the system. Okay. The point is you just don't want any sort of memory leak going on. So normally you would just call VK destroy device or VK destroy instance, but that can get a little bit messy because you don't always know when things are going to need to be destroyed. And normally I try not to use someone else's code directly, but that tutorial that I mentioned before, Alexander Overvoor's vulcantutorial.com, he has a really nice generic template class that he's created called VDeleter. And with this one, you pass in a Vulkan object and a delete function that is associated with it, and it just stores it in this wrapper class. And then whenever whenever the destructor is called, so whenever it goes out of scope, it automatically calls cleanup, which calls its necessary delete function. So in this case, I'm just going to go ahead and use his code. It's way too convenient not to use. I've gone ahead and given him credit for it. I've given a link to the page and his name, and I've added some comments just so it's a little bit more understandable, because, to be totally honest, I didn't get it at first, so it was helpful for me to look through and get a complete understanding of it, and I hope that other people take a look as well. So first off, let's add that to the PV engine. We're going to go ahead to add new item, and this is just going to be a header file, and it's VDeleter. There we go. And I'm just going to copy and paste everything in right there. Alright, now before we go too far, let me kind of show you a little bit about this. So I wrapped it in the same namespace because it is technically part of the engine, so we want to be sure that that can be accessed that way. It's a template type name T, which just makes it a nice generic class. You can pass in any type of object you want. It has 4 constructors. One is a default constructor. That one contains an empty delete function. It's so that you can make lists of deleters, because if you don't have a default constructor, it won't let you make a list without defining all of the values in the list. So this one way we could make, say, a list of, not that we would ever need it, but like a list of 20 deleters in, and then go through and assign them later on. And then there's 3 overloaded constructors. One just takes a cleanup function. Well, technically all 3 take a cleanup function, but the first one only takes a cleanup function as an argument. The second one takes a VK instance and a cleanup function, and the third one takes a VK device and a cleanup function. And then down here we have the destructor, which is called automatically when it goes out of scope, and that triggers the cleanup down here in the private variables. 2 other things I should point out in the private. We have a generic object, which is assigned to VK null handle. It's just a null value. And then a deleter function, which is a generic function to hold whatever its cleanup function might be. So those are used in this cleanup. It takes the object that's being stored, which would be whatever kind of Vulkan object you have, checks if it's null, and if it's not, it calls its cleanup function, and then assigns it to null. So that way this could be wiped and reused if necessary. So before we go too much further in this, something I should point out, all of the constructors use Lambda functions or Lambda Expressions rather, which allow you to pass in a function as a argument. It's kind of a weird thing, and it only works in C++ 11 and up. This is something that I was unfamiliar with, so I actually did a little bit of research on it, and there's lots of information right here if you do a search for Lambda Expressions. They're pretty easy to break down, actually. So some of the things that are kind of important here. You'll notice this is an example of a Lambda expression. It gives you all of the pieces of it. A lot of these aren't as necessary as they make it appear. So the only parts that you actually need to create a Lambda expression are the brackets here, and then the curly braces to create a body. So the brackets are the capture clause, and that's telling the expression what you want to bring into sorry about that, what you want to bring into the function from outside of it. So it pulls in variables from outside, and depending on what you put within those brackets, it will change. So as an example right here, the default constructor left it empty. That means that it doesn't need to bring in any variables. On the other hand, some of the other ones here, this one uses an equals. If you put in an equals, it means bring in all available variables by value. And if there were just an ampersand, that would be bring in all of the variables by reference. And then another option is to designate exactly what variables you want to bring in and how you want them to be brought in. So like right here, it's bringing in delete f because that's the only variable by value. Down here, because we have instance and we have delete f, instance is being brought in by reference explicitly, and then delete f is being brought in by value explicitly. And you can actually have combinations of these. If we go back over here, see this one is equals and total, so it's really however you'd like it to look. The only other thing you need is that body to decide what you're going to do with all of the variables inside. But let's go over some of the other stuff in there. You'll notice right after the brackets you have parentheses. That's a parameter list, and that's going to declare what kind of let me find it on here. There we go. What kind of parameters we're bringing into the function itself. It would be some kind of input. Now there's a couple more parts of this Lambda expression that you can look at. So the next one is mutable. That's not necessary unless you want to be able to modify any of the by value variables that you've brought into it. So if you put in mutable, it allows you to take any of the captured variables that only by value and change them. Then next up we have, where is it? Number 4, throw. That's a declaration letting it know whether or not you need to throw any sort of exception within the Lambda expression. And then the last one is a trailing return type. So normally the return type is automatically generated for Lambda expression. If you wanted to return something specific, you would add that there, but it would mean that you would need to probably use like an auto keyword to grab the variable once it was returned. So that's the gist of a Lambda expression. Really what it does is it saves you space, because you don't need to have other functions to do calculations. You can just put a function directly into an argument and let it do all of its work there. So you'll notice like right here, we've basically reduced it down to one line, which is really handy. So now that we have that, the gist of it is this VDeleter. Like I said, it's just going to capture a Vulkan object and then delete it whenever it goes out of scope. And you can do all the necessary things you would normally do with a Vulkan object with this, because he's overloaded a lot of the necessary operators. Here's a reference operator. He has a replace function, which will allow you to clean up the previous one and then return it. Cast operator, the assignment operator, comparison, everything you need is there. So, since we have this VDeleter now, let's go ahead and actually use that to set up where we would initialize Vulkan. We're actually not going to initialize it just yet because this video has gotten a bit long. So, oh, I haven't actually created the engine yet. Perfect. So we're going to go ahead and add a new class. Okay. And we're going to call this class Planet Vulkan. So this is going to be the main class for the engine itself. It's going to handle a lot of the actual Vulkan calls and that sort of thing. Alright, so here it is. It's not that exciting, but it's there. We're going to need a function to initialize Vulkan itself. So, let's go down here, just init Vulkan. There we go. Init Vulkan is actually going to call a few things when it's being initialized, so I'm going to create another function internally, just a nice private function, for CreateInstance. That's actually going to just create the instance of Vulkan itself. And we're going to get to use that fun VDeleter class that we just made, so that needed a capital. And then within the little brackets there, we're going to go ahead and pass in a VK instance. That's what's created when you first initialize Vulkan. We're just going to call it instance. And then the function that we need to pass into it to initialize it is VK destroy instance. And this is going to give us lots of lovely errors, and that's because we haven't actually included either the deleter or Vulkan yet. So we're going to hop up to the top here. Probably should have done this first just for consistency, but it'll all work out okay. So include, and to include Vulkan, we just do Vulkan / Vulkan.h, and then to use that VK deleter, that lovely thing, we're just going to go ahead and, or sorry, VDeleter. Keep forgetting to capitalize that D. And so that should now be able to use the nice little deleter instance. Let's see if it actually catches up. It doesn't seem to be. VDeleter is not a template, but it is. Oh, is it the namespace perhaps? I think the namespace is messing things up here. Let's see if we add this to the namespace, if it gets a little happier. Ah, there we go. That's what it needed. There we go. So, we've got all that now. And it looks like I also misspelled VK instance, so small k, large I. There we go. Silly mistakes. They happen. So, we have that set up now. Let's hop back over to the planetvulkan.cpp, and we've just created two functions which currently have no place. So let's go ahead and set those up. So Planet Vulkan, and the first one was init Vulkan, and the second one was CreateInstance. And then init Vulkan is going to call CreateInstance. So we have this is a nice public function which can be called from outside, and that'll call the one inside so that everything works nicely. Alright, and I completely forgot to actually give this a type. Making a lot of silly mistakes today. That's okay. I think people can forgive me. There we are. Okay, so everything is set up nicely now. I'm actually not going to create the instance right now, just because it's going to get rather messy, and the video, like I said, went on quite a while now. The last thing I am going to do, though, right now, nothing is actually calling this CreateInstance, and it wouldn't matter anyway because it didn't do anything, but later on when we set everything up, it will. So let's go ahead over to tester game again, and remember the init systems that we had? Let's go ahead. First tester game.h, we have a PV engine window, but let's also make a PV engine. There we go, and this is going to be Planet Vulkan. So that's the Planet Vulkan class, and we're going to make a member variable, which is the engine itself. And once again, we need to actually include it. So PV engine / planetvulkan.h. Alright, so that comes in nicely. So now we have member variables. Let's just bring these down here. There you go. Commenting is always good. So now we have the engine defined, and over here we're going to do mengine.initVulkan. So now it's going to call that initVulkan function over here. That's going to call CreateInstance, and then once we've filled in CreateInstance, our Vulkan instance will be up and running, and we can start actually doing something with that. So that's all we have for this time. Next time I'm going to go ahead and fill out CreateInstance, and I'm also going to start to show a little bit about it's something else that was suggested here in Alexander's tutorial, which I really don't think I can overlook because it's a little bit too nice. It's the validation layers, which are going to show a little bit about how to do error checking in Vulkan, because once again, it leaves everything to you, and it really helps if something can actually tell you what you're doing wrong. And you could have them enabled when you're debugging and then disabled at runtime. That way you don't actually have any sort of it doesn't slow down your program at all. So that's all for this week. Thanks for watching, everyone. Hope to see you in the next episode.